Hi, and welcome to our lesson on the Pythagorean theorem. This is what the Pythagorean theorem looks like. It's a squared plus b squared equals c squared. It always involves a right triangle, and the legs are a and b, and the hypotenuse is c. All some new terms which we'll talk about as we go along here. So this is a right triangle. We call it a right triangle because it contains a right angle, which is right here. The measure of a right angle is always 90 degrees. This should all be review, I hope, from previous years, but necessary. The little square right here drawn in means that it's a right angle, so sometimes it might be close, might look like it, but if it doesn't have that square or isn't indicated that it's 90 degrees, it isn't necessarily considered a right triangle. Or sorry, a right angle too. So about 2,500 years ago, it might be longer now because I'm not sure when this PowerPoint was made, a Greek mathematician named Pythagoras discovered a special relationship between the sides of right triangles. So he realized that if you have a right triangle and you square the lengths of the two sides that make up the right angle, so these are considered the sides, here's your arrows, and you square them, this is why we've done the previous lessons, then you add them together, you get the same number that you would get by squaring the other side. So that means if you go 3 squared plus 4 squared, it will equal 5 squared. If we're given any of this information, 2 of the 3 numbers, we can always find the other side. So let's see if that's actually true. So if you take 3 squared plus 4 squared, does it equal 5 squared? Here we have 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and it does in fact equal each other. And it's true for any right triangle. So here's another example. Here's the sides. 6 squared plus 8 squared equals 10 squared. We check it, and indeed 36 plus 64 does equal 100. So we know that the theorem is true. So the two sides that come together in the right angle are called, sorry, this is a little delayed here, legs. So the lengths of the legs are usually called A and B. Sometimes they'll be called something different, but as we're learning this, they'll definitely be A and B for the most part. The sides across from this right angle right here is called the hypotenuse. You're going to hear that term a lot, so you need to realize it's the side across from the right angle. And the length of the hypotenuse is usually labeled with a C. The relationship between Pythagoras discovered is now called the Pythagorean theorem. So that's what this lesson's about. That's where we're going. We have a right triangle labeled ABC. And the Pythagorean theorem says, given the right triangle with legs A and B and hypotenuse C, then A squared plus B squared equals C squared. This is going to show up over and over throughout your math. It's very important that we learn this and get it down pat. So let's put it into a real world question. Suppose you drive directly west for 48 miles. Then you turn south and drive for 36 miles. The question is, how far were you from where you started? So how do we figure this out? You can see right now that we've got what's looking like a right triangle. So we're going to use the Pythagorean theorem. We're going to go 48 squared plus 36 squared equals C squared. So this is the C is what we're trying to find. So we do the math there. Okay, they're saying why. I'll explain this because it's a right triangle, as I mentioned. And we know C is the hypotenuse because it's directly across from the right angle. And then all we need to do is calculate. So if you take 48 squared, you can use your calculator. You get 2,304, and then 36 squared is 1,296. So we add them together, 3,600 equals C squared, since c squared is 3600, c is 60. And how do we know that? This is going to be based on what we did in the previous lesson. All right, so if you go 36 squared plus 48 squared equals c squared, like on the previous screen. I'm just going to go back there for a second. Okay, right? We found that it's 3600. So 3600 equals c squared. What they're not showing us and we really need to see is in order to find c, you have to take the square root, right? To get that squared sign out of there. So that's where the 60 comes from. So the square root of c is c squared is c, right? Because c times c equals c squared. Square root of c squared equals c. All right, and the square root of 3600 is 60. So that's where this comes from. That's why we did square roots in our previous work. And it's also why we did estimating, because now you can plunk it in your calculator because you'd have the understanding of where that would fit in. All right, moving along. A little slow with these kind of slides. So now it says find the length of a diagonal of the rectangle. So we want to know the distance from the corner to corner. We can tell and know a rectangle has a right angle on both or all corners actually, because it's a rectangle. And our steps are as such. B is 8, A is 15. They're just pulling these numbers. We're just going to focus away from the actual picture here for a minute. Using the a squared plus b squared equals c squared that we know now, I would prefer that you write this out every time. I want you to get used to this formula. So we have 15 squared plus 8 squared equals c squared. They squared them, 225 plus 64 equals c squared. C squared is 289, so we're going to take the square root. And we find c equals 17. Okay, ignore those signs now. So we know that this side right here is 17, based on the theorem that was discovered by Pythagoras. Find the length of the diagonal of the rectangle. Okay, we got the 17, we just did that. So we're going to practice a few of these right now. Sorry, this is such a... Okay, here we have. This is how you're going to write it. A squared plus b squared equals c squared. A and b are kind of interchangeable. One's like they're both legs, so they can be written either way. That's not anything that you really have to worry about. Just make sure that c is your hypotenuse across from the right angle. So we'll put 5 squared plus 12 squared equals c squared. We'll have 25 plus 144 equals c squared. And that gives us, I'm not doing math in my head today very well, so I'm going to make sure I got this right, and I believe it's 169 equals c squared. We're not done because we want c, not c squared. Take the square root, and c will equal 13, I believe. We've now found the other side. Let's see what this tells us. So it'll probably overwrite me here. Here we have 13. All right. Another one. This is different now. Now we're given c. It's very close, or very important to pay attention here. Again, write the formula. A squared plus b squared equals c squared. Plug in the numbers. We don't know b, so we're going to leave b squared alone. We know a, because it's a leg, so that's 10 squared. And we know c because it's the hypotenuse, which is 26 squared. Okay, I'm going to pull out my calculator for some of these bigger numbers. 10 squared I know is 100, plus b squared. Keep the formula going here. 26 squared is 676. And now what? Because we have to find b. Now you're going to go back to grade 7 algebra, where you had to even out your sides. So we need to get b by itself, b squared by itself. And in order to do that, we need to move this 100 out of here. Right? So we're going to subtract 100. Then it's gone. Right? Cancels out. But whatever we do to one side of the equal sign, we have to do to the other. So we're going to subtract 100 over here. So basically, I'm just going to write this out. 100 minus 100. You don't ever have to do this, but if you put it up here, that's a good idea. I just want to break this down in case you've forgotten from last year. So 100 minus 100 is 0, so that's gone. So that's how b squared will give us 576. And then we're going to take the square root, because we don't want b squared, we want b. And now you can plunk the 576 in your calculator and use the actual square root button. And it will give you 24. So now we know side b equals 24. Alrighty? You can always go back and watch this and redo these steps. They're going to show you the same thing. A squared plus b squared equals c squared. Here we have it. They don't do the minus 100 up here, and you don't have to do that if you've got that in your head and it's just gone and you know to pull it over here. That's fine. It's just showing this work is just as good. And b squared equals 576. I don't like that they're not showing the square root sign, so make sure you add that in your work so you know where this 24 came from. Okay. I'm just going to skip this one. All right, so that's the end of this lesson of just breaking it down to a squared plus b squared equals c squared. If you were given the same idea, if you weren't given a, let's say, I'm just going to draw a triangle here. So let's say we have, I'm going to use these numbers, 15 and 12 and a. You would do exactly what we did on the last page. All right, you'd write your formula, plug in the numbers. A we don't know, b is 12 because it's a leg, 15 is c because it's the hypotenuse. Okay, we'll have a squared plus 144 equals 225. I'm making sure because my brain isn't working as good as it usually does. 225. Sorry. A squared equals 225 minus 144. Show this step. That's important. I need to see that in your work. A squared equals 81. Okay, we're going to square root it. A equals 9. All right, so I used these numbers up here. This isn't actually this triangle. Really, this is what it would look like if that was where I started from. Okay, so again, go back over this work, follow the steps, and I'm going to give you a worksheet just to get used to this sort of thing, and then we'll move on to the next lesson after you've done that assignment. All right, I'll catch you there.